Mathematical induction, that's right. All right, so which side have we decided to work with? We're going to work with the left-hand side. So I'm going to write that down to keep you guys motivated here. So we're going to work with the left-hand side. Pick that side. That means we cannot change the right-hand side. Okay, on the left-hand side, we have cosecant of theta, and we have multiplying that by tangent of theta. Look at your toolbox right now, and look at what options are available to you for cosecant. Daniel, give me one of them.
The Pythagorean identity.
No, that's not it at all. Give me another one. Look in the first box. Basic identities, cosecant, what is it?
1 over sine.
Okay, we have 1 over sine. That's available to us, right? Look on the back. Cosecant is also what?
1 over sine.
Good. It's in both places. What about the tangent? What's available to us there?
Sine over cosine.
Sine over cosine, or
1 over cotangent.
1 over cotangent. Okay, so lots of things are going on. Would anybody like to try any one of those things? Olivia, what do you got?
You should change cosecant to 1 over sine, and you should change...
Wait, one thing at a time. Hold on a second. I'll come back to you. She says change cosecant to 1 over sine of theta. So that's what I'm going to do. I've changed the cosecant to 1 over sine theta. All right? And Olivia, let's continue with you.
Then you should change tangent to sine theta over cosine of theta.
We should change tangent to sine theta over cosine of theta. Okay, now does anybody see anything beautiful that happens to you? Happens. I see only 2 people in the room see it. 3, 4, 5, 6. Good. Randy, what is the most beautiful thing that happens right now? The signs cancel out. That's exactly right. You're multiplying fractions. Now, what are you left with? 1 over the cosine of theta. Okay, look at your toolkit identity. What is 1 over the cosine of theta? Secant of theta. So, now, I allow everyone to just draw an arrow down the right-hand side so that you do not have to keep rewriting the right-hand side of secant. As long as you tell me that somewhere on the page, you're going to choose to work with the left-hand side. Okay? That's a bunny hill. Okay. Okay? Another bunny hill. We have the cosecant of theta multiplied by the cosine of theta is equal to the cotangent of theta. Okay. First things first. Anna, which side are you going to choose to work with? The left-hand side or the right-hand side? She said the left-hand side. Who agrees? Who disagrees? Who has no idea? Okay, yeah, we're going to go with the left-hand side, right? We're going to go with the left-hand side. There's more options available to us, all right? All right, cosecant. Anybody see anything valid that we can do with cosecant? Daniel, I'll call on you one more time. What is it? That's 1 over the sine of theta. Good. I need somebody else. Do I do anything with the cosine of theta? Nay. Okay, let's leave it alone, right? All right, so that leaves me with cosine of theta divided by sine of theta. Okay, look in your toolkit. What is cosine divided by sine? Cotangent theta. The green circle. Here we go. Green circle on the left-hand side. Big green circle. Now, this one says the sine squared of negative theta plus the cosine squared of negative theta is equal to 1. Okay, so we're probably going to be using which of the 2 identities combined together. Can anybody have any guesses on the toolkit? Pythagorean and even and odd. Beautiful work, okay? We're going to use the Pythagorean and even and odd properties. I'm going to start by showing you a trick. And this is a trick that you want to have in your back pocket here. When you're dealing with trig functions, you're allowed to take the sine, negative theta, and move it outside here. Because notice the even odd properties don't say anything about square root of theta. So we need to get that out of the way before we can talk about even odd properties. Plus, this would be the same trick over here. Cosine, negative theta. Oh, that's terrible looking. Quantity squared. So I'm assuming, by the way, we're choosing the left-hand side since there's only 1 on the other side. Not very exciting. All right, great. Now, even odd properties here. Even and odd properties. Even versus odd properties in this case. Okay, tell me, what is the sine of negative theta? It's the negative sine theta, right? Because sine is an odd function. So I've got negative sine theta, quantity squared, plus, what's the cosine of negative theta? Even odd properties. Positive, because that's an even, because cosine is even. So I got cosine theta. Quantity squared equals the thing on the right-hand side. Now, if you take anything, no matter what it is, and you square it, what does it become? It becomes positive, doesn't it? So this gives us sine squared theta plus cosine squared theta. And of course, what does that equal to? 1. Which side do you guys want to work on? Yeah, we all choose to work with the left-hand side. I would agree. There's more options over there. So let's work with the left-hand side. All right. Anybody got any thoughts or ideas on this one? I don't. Make it a single. Make it a single. Try and get that fraction to be a single fraction. Okay, let's turn everything in terms of sines and cosines. So we're going to do that too. So let's do this. 1 plus tangent in terms of sine and cosine. What is it? Sine theta over cosine theta divided by 1 plus, what's cotangent? Cosine theta over sine theta. All right, good. And then equals on the other side. All right, great. Doing good so far. All right. Let's take a look at the numerator. 1 plus sine theta over cosine theta. What would I need to make the numerator a single fraction? What would I need? I don't know. You're going to play the what's missing game on the 1. Oh.
Oh, you could make it a fancy one.
That's exactly right. And what would that fancy one look like, Daniel?
Cosine over cosine.
That's my class. Yes. You're looking for this. Let's change this to cosine theta over cosine theta. After all, that is just a fancy one. I'm allowed to do that, aren't I? Without compromising or breaking any of the rules, right? Now, do the same trick on the bottom. What would it be? Oh, now we're getting somewhere. Okay, this is going to be sine theta over sine theta.
I kind of would consider that as like doing what you do to an equation, like the one you learn not to do, you know?
No way, man. I'm not working across equal signs. I am using a fancy one. I'm allowed to do that. Doesn't say anything about no fancy ones, right? Not that it would, but whatever. Okay, now, what does the top become? Simplify your fraction for me, please. What do I have? Cosine theta. Okay, I'll go with you. Over cosine theta plus sine theta over cosine theta. Simplify your denominator for me. What do you have?
Cosine over sine?
No. What's it say?
Sine over sine plus cosine.
Sine theta over sine theta plus cosine theta over sine theta. Okay. Now simplify your numerator again for me.
Sine over cosine.
No. Yes. Thank you, right? Thank you. This is cosine theta plus sine theta, all divided by cosine theta. Correct? Single fraction. On the denominator, what's my single fraction? Sine theta plus what? Cosine theta all over sine theta. Okay, now. Oh, who sees it? Anybody see it? I got one who sees it. Anybody else see it? 2, kind of. He hasn't even been here for 10 days. He sees it. Yeah, you see it? Sort of. Okay, I'm going to do something for you here, though. I'm going to highlight this so you can keep track of it. I'm going to highlight this. All right? No, now you see it. What do I do when I divide two fractions? Yes. I flip and multiply. So this is going to become, I'm kind of running out of room here. So I'm going to go here. Cosine theta plus sine theta, all divided by cosine theta. So this part has not moved, correct? Multiply by sine theta divided by sine theta plus cosine theta. And this part is now up there. The blue has become there. Flip and multiply. Now, anybody see anything beautiful that happens? What happens there? They cancel out. What's that leave me with? That leaves me with sine theta over cosine theta, which of course is tangent of theta, which, oh my gosh, way back over here. A super long arrow. You need to draw it. We'd ask ourselves first. Adrian says what? And there you go, left-hand side. There you go. You got to pick a side, right? I'm with you. And then what?
Can we make them all sine and cosines?
Yeah, that's a great idea. All right. So sine theta. So cotangent becomes what, dude? Cosine theta over sine theta. I'm with you.
And vice versa.
The reciprocal, okay. So that would be sine theta over cosine theta. Good, I'm with you. Now what?
Distribute?
Well, if we do, we lose something. We should work inside the parentheses first. I'll just leave you there.
Wait,
That's a 1.
why didn't we just make it 1 over tangent plus? Just kidding.
Okay.
Never mind.
So what game are we playing yet again in this class? A fancy one game. So where does the fancy one need to go? We play this game every day in this class. What goes here? What? Sine over sine. Sine theta over sine theta. What goes here? I'm running out of room here. Cosine theta over cosine theta. That's a fancy one, right? No rules broken. Oh, my highlighter just went crazy. No rules broken here, right? That's terrible. Look at that mess. Let's make that better for you. Okay, fancy one. All right, team. Here we go. I got sine theta on the outside. Help me out. What's cosine times cosine?
Cosine squared.
Yeah, cosine squared theta. What's sine times sine?
Sine squared theta.
All divided by what?
Sine or cosine?
No. What's the common denominator?
Sine cosine. Sine times cosine.
Sine theta times cosine theta. The common denominator, right? All right, now.
Squared plus cosine squared is 1.
Dang. Ah, okay. So this is going to be 1 divided by sine theta.
Oh.
Oh.
And you can cancel that out.
Oh, and then she says you can cancel these out. What's that leave you with?
1 over cosine, which is secant. There
Oh,
we go.
which is secant of theta, which is what you were supposed to find on the left-hand side. Check that out.